Hello, everyone. It's strange to hear myself through the microphone, but hopefully it will work. Nice to see many of you here to learn more about data reliability engineering. So over the next 20 minutes or so, my colleague Akshay and I will talk to you about some of the lessons we've learned in this space, often the really hard way, and give you some kind of insights that you can take away and apply to your own projects. It's worth calling out that the topic today is data reliability engineering, not SRE. So you may well find that some of this is not something that you work on regularly, but hopefully it will be useful enough to be able to use when you do work on a data-related project. This presentation is also fairly high level. We only have about 20 minutes, so if you want to come find us after to talk more about some of the nitty-gritty detail, please do reach out. So, Akshay and myself, we are consultants with Sahaj Software. We are data and platform engineering consultancy. And over the last year or so, we've been working with a large scientific publishing company in the UK to help them build a harmonized reporting view of their portfolios. So it's worth giving, first of all, a brief introduction into this project, which has been such a fertile ground for learning about data reliability engineering. So before we came along, the reality on the ground was kind of this. So this business has many important sources of data for analytics, for reporting, but the availability was kind of really quite patchy. So at one end of the spectrum, we had some data that was just not available at all in their data warehouse, so it couldn't be used. At the other end of the spectrum, you had data that was looked after by a team. It was well curated, transformed and interpreted and provided to downstream consumers. And then you had everything in between as well. So you had sources of data where only the raw data, whether that's of a relational nature or event level data, was available in the warehouse, but very little or no guidance to people how to use it or how to interpret it. So the impact for consumers was that you ended up with some data being interpreted differently by different teams. And you can imagine how that can lead to some very uncomfortable conversations with senior stakeholders when one number in one report says one thing and another number means something completely differently. Some data was just left out of reports altogether, so it wasn't measured. And like Peter Drucker would say, if it's not measured, it's not managed. And often what would happen is people would have to figure out the meaning of data themselves and kind of make some educated guesses, but that would inevitably lead to mistakes to be made. Fast forward to today, where we are today is that we've identified owners for each of the source systems that are in this business, the important ones. We've worked closely with them to make sure that their data is curated and interpreted consistently and made available consistently downstream for use. For consumers, what this means is that I'm realizing now that it's a bit clipped.
But I think it's fine.
Hopefully, yes. I don't think. Oh, there we go. Nice, Akshay to the rescue. But the impact today for consumers is that there's now an aggregation team. Currently, it's made up of ourselves as Sahaj team, sitting in between data consumers and data producers, facilitating those conversations between, I want this, I need this, that consumers often come up with, and data producers saying, I can do this, or I can't do this for you. So now that we've given an overview of the messy data landscape we've been operating in, it's time to zoom back out and kind of give you an overview of what a data product actually is. So a data product typically has kind of three distinct areas. So you've got your inputs. These are the data sources that you consume from outside the boundary of your own data product. At the other end, you've got your data output, and these are the things that you put in the hands of your consumers. This can be a dashboard, a report, a table in the data warehouse, a well-curated data model in the data warehouse, a dashboard, any or an event stream or anything like that. It's what you put in the hands of your consumers. And then you've got everything that's under the hood of your data products. These are your internals, your cleaning and transformation, your interpretation, your aggregation on top of the data, anything that you do to your inputs to turn them into outputs. Now, two very important call-outs here. One is that your input can be someone else's data product. And two is that your outputs can be someone else's data sources acting as inputs into their product. So in this business, there's a bit of this kind of like network graph of data products created by and maintained by some teams. And then those are used to create other derived data products maintained by other teams and so on and so forth. So it's worth keeping this view in mind, because it will become, you will see how it is relevant to all the facets of data reliability engineering. So with that in mind, I'm going to pass over to Akshay to talk to you about data contracts.
Okay. So now that we understand a bit more about data products and the different teams, producers, and consumers involved, let's start talking about data contracts. So data contracts are basically an interface between the consumers who are using data and the producers who actually provide data products for the consumers. So they basically act as an agreement of sorts. So just like in software development where you have service contracts or APIs, in the data world, you have data contracts. So the whole point of having data contracts is so that you start building a better understanding or the collaboration between the producers and consumers. So this is where you will start setting up expectations, any sort of policies, testing, all of this can be documented as part of your data contract. So to understand a bit more about data contracts, let's talk about what is it made up of. So like I said, there's quite a few things that go into a data contract. There's expectations, metadata, policies. And yeah, I can't dive into depth in each of these, but if you want to know more, reach out and we'll talk about the nitty-gritties. But the main things over here are, so the system of origin. So like Carmen was saying, whenever you're building your data products, the inputs that you have are someone else's data products. So you don't necessarily control what is coming into your system. And this affects how you start building your data contracts as well. You need to start modeling your schemas. You need to start understanding what are the different inputs that you're getting, how are you going to collate them, and then present them to your consumers. So you start working with your consumers and producers together, start getting them into a room, and then start understanding what are the different tables that you want to provide, what are the data types, what are the constraints that they should consider when you're making your data products available. The other thing to consider is also how frequently does your data product update itself? And this can be a big range, right? So this can be if you have systems or consumers who need data real time, you will have to think about how do you implement it. Maybe you need to have a streaming solution. Or if someone comes and says, oh, I only need this data weekly or daily, you could go for a batch-based approach. So implementation details are also defined by the data contracts themselves. Other things to consider, quality metrics. So this is where data contracts and then software engineering and SRE, they start to differ a lot, because when you have quality metrics, there's very different metrics involved with like accuracy, completeness, freshness that you may not consider necessarily when you're thinking in like SRE terms or like traditional software engineering. And there's other things here as well. Just capturing known limitations, documenting governance policies, GDPR, those all go on top of and are part of your data contract itself. And you should start having these conversations early on when you're starting to build your data products, because what that helps to do is it helps you set expectations up with your consumers and also start building more collaboration between producers and consumers, because they start talking to each other. And this brings me to what are the lessons that we've learned when we started building and talking about data contracts at this client of ours. So the very first thing we learned is that, so at this place where we started working is the way their teams were composed is the analytics and reporting and data science teams were a completely different team or multiple teams or even part of a completely department than the software engineering teams. So what started happening is that whenever these reporting teams needed any data, they would ask for a spreadsheet with like, here are the fields I need, go make it available. So they weren't really embedded in any of the software engineering teams. So this is where we started to notice that there are a lot of silos and people are just working in their own thing. And then when we went in, we started to implement data contracts. We started to notice like, okay, we need to bring people together and get them to talk to each other. And when we started doing that, people actually started understanding each other's needs. So producers started to understand what are the different ways in which people will use your data? What are the use cases that will be enabled? And then consumers as well started to understand the limitations that come with the data product. What are the kind of things that I can do with a certain data set and what I shouldn't do with it, which will give you the wrong insight that you weren't thinking of. So those are the kind of things it started enabling. The other thing that came out of this is people started to think about data as a product. So it brought this product-based thinking in data. So this is where people started to have discussions between themselves. And we kind of formed this working group of sorts that used to come together regularly, discuss, okay, as part of this particular table, what are the kind of columns that should be there? And they also started to get a shared understanding when they talk about in this particular domain, what does a submission mean? What does a researcher mean? What are the fields that are there? So they started to talk to each other and understand. And then like we started to build this collaboration between the consumers and producers. And that eventually brought some more trust whenever people were using our data products. And the way we did this is by having a document. So we just went to this normal spreadsheet where people would put in, okay, these are the kind of data points we can provide. And then consumers would say, okay, I can use it or I can't. So we had some collaboration of sorts there. And it also started to help us understand what are the use cases we can enable, how should we even approach building this data product so that we can build an MVP of sorts that will enable a few business critical use cases, but then we can build on top of it and take it from there. So when it comes to implementing data contracts, so Carmen spoke about the different inputs that we have on the left. So as part of building our data product, the very first thing we had to do is we had to agree on a contract of sorts with each of our source teams. So we had to understand what are the kind of data points they can provide. And then all the components that I had mentioned earlier with schemas, with the inputs, with the freshness. So we had to agree on a contract on that. And the very first thing we did is before ingesting that data, we had to test that it met our contract. And then similarly, we would transform our data once the data had been ingested, and we would also test our own contract to make sure that the outputs were aligned with what consumers would want. So this is something for you to consider when you are going to build any of your data products. Start from the edges, validate your inputs and outputs, and then take it from there. All right, going to validation.
So Akshay has given you a really good overview of data contracts. So obviously defining them is only step one, but then how do you go about validating them? So if we take this kind of simple data model for this business, so this business has multiple journals. Each journal can have one or more submissions in flight or published, and each submission may or may not be in a collection. So you would start validating your data contract. You'd start with the basics. So you would validate your, initially your schema, your column names and your data types are what you expect. And then you'd move on to a bit more kind of the nitty gritty of the data. You'd validate your constraints and your relationships. Now, we found that the most common violations for us were around uniqueness and referential integrity. And that is because many of the systems that we work with either don't define these or they don't enforce them. And the data often arrives through the pipeline at different rates and it lands in the warehouse at different rates. So that kind of creates gaps in relationships. But the key point here is that you probably want to invest more time in the areas where you're most likely to encounter violations or where you think that there's a high risk of violations happening. And that will depend from source to business to project to project. But it's kind of worth knowing where to invest your time in particular. And the key lesson for us here was get comfortable with unexpected data and plan for it because it will absolutely happen, and make sure that your systems can deal with it. Unlike software engineering, you just don't have the luxury of controlling your input data. How many of you have followed the news about the UK airspace fiasco on the bank holiday Monday, where about 1,500 flights were... Yeah, I was meant to be in Greece in a tiny little village with a handful of tavernas. I ended up in Spain 4 days later, down the road from Magaluf. So not what I expected, right? And incidentally, when all that happened, and then I realized that I followed the news, and they said there's 1 in 15 million events where that one flight plan that was submitted had 2 kind of portions of like duplicate data. And that is exactly this slide. It's incidentally that I put this slide together before I went on holiday. So absolutely get comfortable with that because it will happen. Probably not with such disastrous consequences like hundreds of thousands of people stranded overseas. But yeah, definitely keep that in mind. So now that you've validated your data contract, it's time to think about validating your interpretation of the data. And this is absolutely something that is unique to data engineering, at least in my opinion. So, for example, a submission has this field called is currently in collection. And you can totally have a situation where this field satisfies all your contract. It's a Boolean field. There are no null values, etc., etc. But how do you know if the interpretation is correct? Because ultimately, this field is a matter of business interpretation. And what I mean by that is that a submission can be treated as part of a collection if any number of these rules is true. And how do you know which rule is the right one? Well, that is exactly the point. All of these interpretations can be correct in a given business context. So how do you validate when there's like no cookie cutter way to validate what essentially matters of opinion? There's no package that you can install and tell you whether you have correctly interpreted the value for this field. What we found very useful is kind of 2 strategies. One is that in the initial implementation phase, you want to make it as easy as possible for stakeholders to see that the interpretation that's running in production is what they actually wanted, and it's what they actually think the meaning of data is. And whether you use, Python, SQL, Spark, or any other programming language, strive to make a code as readable as possible to the layperson. Because what you can then do is you can actually link to this from your documentation, and stakeholders can look at this and say, oh yeah, I can totally see that this is a definition I wanted them to implement, and this is how I'm going to interpret the data on my end as well. And what we'd also say is that if there's any additional business context that explains why a certain interpretation is being made, also document that, because this is the type of knowledge that often lives in people's heads, and people move on from businesses and that knowledge gets lost. So persisting this and making it part of your living documentation is extremely useful. It may not be sexy, but it comes in very handy. So once you have established that your initial contracts with in matters of interpretation are kind of satisfied and kind of like implemented, how do you then make sure that when you do implement changes, you don't create kind of any unintended consequences for those interpretations? Well, this is where it's time to think about the data equivalent for regression testing. And a very generic mechanism that we've got in place, that's actually running in production now, is this kind of like deep difference check. So basically you take your input, the same data, input data, and you pass it through two versions of your pipeline. One is got logic that's running currently in production. The other one is kind of this other branch where you're making changes. Both pipelines produce the same set of outputs that you put in the hands of your users, right? And the only difference between them is that something along the guts of the internals, interpretation-wise, has changed. Now, what our mechanism allows us to do is it allows us to compare each output as well as all the interim artifacts that are being produced along the way, one by one. And that is very valuable to use in three different ways. The first one is that it allows you to confirm that you haven't made any unintended changes where you didn't target them. So here, you weren't targeting any changes in dataset 1. So this allows you to confirm that, okay, fine, we've not changed anything there, we're all good. It allows you to detect that the change where you did intend to make one, there is a change, there is indeed a change. And it also allows you to then establish that if the difference isn't what you expected, that you have instead of going down various rabbit holes, you have a clear breadcrumb back to where you've made a change. And it allows you to understand why it's produced an unexpected result. So this has saved us a lot of time and lots of headaches and lots of avoided many situations where we would push bugs into production without us intending to, obviously. This is kind of quite unique to data engineering, especially when it comes to matters of interpretation. So with that in mind, I'm going to pass over to Akshay, talk to you about data monitoring.
Yeah, thank you. So yeah, we spoke a lot about validation and testing and improving your pipeline before you deploy things to production. But once things are in production, how do you handle it? So this is where data monitoring comes into picture. So we took a lot of our learnings from software engineering and SRE. We tried to apply those for data monitoring. So just to speak a little bit more on that. So when it comes to facets of data monitoring, what are the things that you should be looking for? So ideally, you want to monitor all of the things that you've captured as part of your data contract. But most importantly, these are like the kind of things that you want to focus around. So you want to make sure that you are actually using fresh data every time you run your pipeline. So any sort of contracts that you've established with your sources around freshness, you want to make sure that you monitor those as well before you start running your pipeline. The worst thing you can do is like run your entire pipeline and then find out that it was actually using stale data. So you need to make sure that you have monitoring and alerting around that. I'll give you some examples where we actually had production issues and how we tackle them later as well around freshness and all of them actually. So validation as well. So Carmen spoke a lot about how we test things, how do we improve data quality, but we also monitor that. So every time our pipeline runs, we also run a bunch of tests in production. So we capture those results and we store them in a database of such so that we can revisit that to see if something has failed, how many times has that test failed? Because in most cases, we don't control the inputs. We want to know if something is changing around the inputs, do we need to revisit those contracts? If there are any sort of SLOs or SLAs that you're agreeing with your customers, you need to make sure that you're producing reliable data all the time. So this helps you inform any sort of changes in patterns and start detecting and like revisiting any of those contracts at a later point. Another aspect which is kind of different than software engineering here is volume. So volume of data, you need to make sure that whenever you're delivering a data product, it's complete. And you may have agreed upon any sort of SLOs with your consumers to say like, okay, it's always complete or it will be like 99% complete. But you need to know that it is in fact complete. Another thing that you can do with volume is you can start capturing if there are any sudden changes. So you need to capture any sort of changes in time with volume. And I'll again give you an example later of how you can use things like standard deviation to capture any sort of spikes in the volume so that you can detect, is this what we expected to happen or is this a bug that we introduced by mistake, or so on. So just to give you a few examples, so these are all production incidents that we've had. So this one was around freshness. What had happened is one of the sources that we use in our data product, it hadn't been updated in a few days. And we've basically configured our pipeline in a way that it will basically warn us anytime we start using our data and it's not refreshed at a certain threshold. It will alert us in Slack. And these Slack alerts are also visible for all of our consumers. So they can actually go into that Slack channel and see what is happening with our data pipeline. So they see this alert. And the other thing that you'll see right below is, okay, we've started a thread. People are working on it. So this is where you start building trust with your consumers. You start having transparency around like what is happening with your data product. If there are incidents happening, how are people tracking this? And just to call out on the tech stack, there's a bunch of open source tools that we use here. I won't go into a lot of detail here, but yeah, reach out later. And then there was another incident where one of our data contracts had failed. So this is again where we expected a certain field to always have not null values, but suddenly the source where we were consuming data from, it started to have null values. So this is where like a Slack alert was sent. We investigated, we worked out with our sources what exactly was happening with the data they were providing. And then we basically ended up, okay, we understood that, okay, this is basically a test data point that they've started to send, and we could exclude it. So basically it allows you to understand what is happening with your data product and investigate, and then update your contract to either exclude that data or to let your consumers know that, okay, your data contract is changing going forward, and so on. So this was a fun one where, so again, like I said, we monitor the volume of data being ingested as well, and same with the outputs as well. We monitor the outputs as well. So we were basically counting the number of rows that we get from this particular source, and an incident happened where they pushed a change, and it basically doubled the number of rows that were being pushed out into that table. Now what happened here is that luckily we do have alerts, and then this was caught by like a standard deviation alert where it exceeded a certain value, and then we got alerted in Slack. We found out, we again spoke with that particular producer, and even they weren't aware that they had actually made this change by mistake. So this is where you can like build much more trust early on, like you can catch things early on, instead of someone then using your data product later on, pushing it into a dashboard and then finding out that, oh, why has this particular count that I expected to be like between 4 million suddenly gone up to 8. You don't need to wait for that to happen. You don't need to wait for like your executives or anyone else who's using your dashboards later down the line to come and ask you. You can find that out early on and then like fix the problem at the source when possible. So these are the kind of examples that you can learn from and then like implement in your data pipelines going ahead. So yeah, given me a shortened time, this is just roughly like the summary of the learnings that we've had. And yeah, I'll open it up to questions. Thank you.
Any questions? Be as fast as possible.
Thanks. Yeah, I'm interested in how to track data lineage and visualize that. I know there are some products out there, and I wondered if you had any advice on how to collect that kind of data, how to kind of form that and monitor it as well.
So lineage, there's many different ways in which you can do this. This also depends on how you've implemented your data pipeline. In our case, like I mentioned, we are using something called dbt, which gives you a way of visualizing what are the different steps that are involved in your pipeline, how are you ingesting your data, what are the transforms that are happening, and you can visualize it. But there's a lot of other tools out there as well. They are in quite a lot of infancy right now. So you'll see a lot of monitoring tools that are trying to build the lineage capabilities into their tooling so that you can look at into your dashboard what is the lineage. For us, we are on GCP. So recently, they've also enabled a lineage API. You have to pay extra for it, but yeah, you can visualize exactly what are the BigQuery tables that are used as inputs for you, and then what is being used for the downstream as well. So it will really depend on the kind of tooling. If you're interested, yeah, I can talk to you more about DBT and lineage and those kind of things.
There's one thing I want to add here is that most of the lineage tools that you have today only show you like the steps in a pipeline, but they don't really do anything for the interpretation side of things to help you understand, okay, this raw data point here ended up transformed and interpreted in this way and why. I would imagine that now in the world of kind of ChatGPT, if your code, your transformation code is written cleanly enough and detailed enough, then you can probably kind of feed it to a tool that will eventually use AI assistants to understand how the data is transformed, not just tell you it's gone from A to B to C to D, but actually give you more of a nuanced understanding of how it's been transformed and where, which as a data engineer, that would be amazingly useful, but I don't think we're quite there yet.
All right. Thank you so much.
Thank you.